Good morning, everybody. Welcome to sunny Tuesday morning of Chem 1105 with your host, me, Dr. White. Hey, everybody. All right, before we get into today's lab and other stuff, there's some announcements I like to make or reminders. All right, first reminder or announcement, I have postponed test number 3 by 1 week. It won't be tomorrow. It will be given next Wednesday, the 26th, right after class at 12 p.m. approximately. The other thing I'd like to remind you is the lab amnesty program. I've given you until Thursday, the 27th next week to get all your labs in that you haven't done that are overdue or late. And if you don't have those in by the 27th, I will be putting in a 0. If you do hand it in, you only lose 1 point if you did everything right. So it's your advantage. If you haven't handed in labs, hand them in, do them and hand them in. If you need any help, contact me by email, come to my office hours, see me after class. And let me remind you, because the last week of the medical emergency, you should watch these two YouTubes to cover the material that I would have covered last Wednesday. And with that, let's get to work. All right, what are we going to do today? First of all, we'll do the lab, actually 2 labs, and then we will continue with solutions. All right, the first lab deals with investigating chemical reactions. Now, let me remind you, you should be using proper protective equipment, safety goggles, gloves, and I'd wear the apron, or another thing, I'd also wear a long sleeve top. Because a couple of the chemicals you got to be careful with. They're not super dangerous, but you should be careful. All right, today's lab involves investigating chemical reactions. In general chemistry, different from organic chemistry, there are a couple of main types of what we call named reactions that you will be investigating. What are those named reactions? Well, let's find out. The first one is a synthesis reaction. And a synthesis reaction is where you take 2 things, react them together, and make something else. And here's an example, A plus B makes AB. Now, the second type is a decomposition reaction. Decomposition falls apart. And here, the example, AB falls apart to A and B. And an example of that is right here. If you take water and H2CO3 is called carbonic acid. And as soon as you form that, quicker than I could do that, it decomposes, which is why it's called a decomposition reaction, to water and carbon dioxide. Now, just to remind you, the little letters in the bracket to the right of a chemical symbol, S is for solid, G is for gas, L is for liquid, and AQ, you know that. That means it's an aqueous solution. It's that chemical in water. Now, the third type of reaction you'll be investigating is called a single replacement reaction. If you have A plus BC, the B in BC is replaced by the A, and the B is kicked out. Chemists are violent, kicked out. And here's some examples right here of single displacement. Now, you can also have double displacement That's like when you're shuffling the cards, everybody swaps partners. And here they give a general way of looking at it. I can highlight it. Doesn't want to be highlighted. AB plus CD, and you swap the B for D and the D for B, and you get ADBC. And here's an example right here. Well, doesn't want me to do highlighting. Sodium chloride plus silver nitrate, AgNO3, gives you sodium nitrate, yes, NaNO3, and silver chloride. And notice the silver chloride is a solid, meaning it would precipitate out. Now, one special type, which we'll really cover well in chapter 7 coming up, is called an acid-base reaction. And here, HCl is an acid, sodium hydroxide, NaOH, is a base, and they neutralize each other. I'll teach you what that means, to make sodium chloride plus water. Now, the fifth one is called a combustion reaction. And a combustion reaction is where you react oxygen with something to make something else plus energy. That energy is in the form of usually heat. And example of combustion, when you cook your food over a gas burner or in your gas oven, the heat that cooks the food is created by the gas, methane, natural gas, reacting with the oxygen, combustion, and that's the flame which gives the heat. And here's the reaction right here. CH4 is methane, natural gas. With oxygen, you get carbon dioxide, water, and energy. Now, they have here evidence for a chemical reaction, and they have one here which we won't be dealing with, that's pH change, but I'll talk about the key things in a second, maybe more than a second. Now, one of the reactions you'll use is when you test for hydrogen gas, and this lab, let me tell you this, you're going to be using a candle with fire and some splints where you'll be burning them. When you do that in the area you're working with, I'd work in a kitchen. I'd also, as I told you, get one of those aluminum foil pans to work in. Make sure there's nothing flammable around, no paper or anything like that. Stay away from curtains. I'd actually do it in a sink with the metal pan. Now, they say a cookie sheet, a metal pan, I showed you last time. Let's do it again. I can find it. Here we go. I would highly recommend, you should all be able to see on your screen now, we're at Walmart for the expensive price of $1.24. You can get this baking pan, and I would do the reactions in those near a sink. Again, You're going to be working with a flame at times. Make sure there's nothing flammable nearby. No papers or anything like that. All right, let's get back to the lab. Now, to test for hydrogen gas, you put a flaming splint, meaning a wooden stick, into the container like a test tube where the gas is. And don't be frightened. You'll hear a loud pop like that because the hydrogen gas just immediately reacts with oxygen to give off water as a gas and that energy. And part of that pop is the energy. Now, to detect for carbon dioxide, you'll react that gas with calcium hydroxide, otherwise known as lime water. And what happens is you get this double replacement, I think that's what it's called, and you will get a solid form, the calcium carbonate, plus water. Now, here's the different things you'll be using from your kit, and you should have all this. Again, wear proper safety equipment. You should have your safety goggles on. You should wear gloves. And I would wear the apron or especially also wear a long sleeve top to protect the skin on your arms. Now they show you how to do certain things like here, how to make this rubber stopper with the plastic tube that you cut from one of the eyedroppers. Important tip, when you're trying to get it in there, put a little in the hole, a little soap that will lubricate it. You could also just try water too. And you'll stick it in and just twist it in. And the same thing when you put the plastic tube on the top of that, lubricate it with a little water or soap. Don't get the soap in the tube. All right, number one activity. What will you be doing? You'll be taking 50 milliliters of vinegar, which you measure out in your graduated cylinder, pour it into a cup, plastic cup you have, measure the room temperature using a thermometer. Remember, place the thermometer, and they say a rubber band, on a paper towel. That way it won't roll off onto the floor and break. And with protective, take a piece of half the steel wool on a paper towel. That way you won't get stuff underneath on your countertop. And what you'll do is put half of that in the cup with the vinegar, press down, make sure you have your gloves on, let it sit for 2 minutes, remove it, wrap the steel wool around the thermometer, use the rubber band like it's in a picture, and observe the temperature, recorded at 5 and 10 minutes. And then discard everything. What I would do is take the steel wool with your gloves on, put it under some cold water, squeeze it a couple times, then it's good to go in your garbage can. All right, let's look at the reaction. You gotta turn on how come my pad isn't, I didn't turn it on. Now we're good to go. What's steel wool? Iron. What is vinegar? It's water and an organic molecule called acetic acid, CH3CO2H. Now, this hydrogen is called acidic hydrogen. I'll teach you that. And it reacts, and what you get is this reaction. And this is for activity number 1. And what you will have to do is balance it. That's part of it. All right, let's go on to the next one. And this is investigation number 2. This uses hydrogen peroxide. Make sure you have your goggles on. You never want to get that in your eyes. Make sure you get your gloves on. That's also known as bleach, or one type of bleach, like the bleach your hair. I wouldn't use that stuff because I don't think it's for that. But what you'll do is you'll measure out 10 milliliters in a graduated cylinder, put it in a test tube, put the test tube in a large empty, your plastic 250 milliliter beaker with your mini spoon, open the packet of yeast and put in two spoonfuls into the test tube. And then what you'll do is observe it, gently swirl the test tube. Now, to mix it, the best way is, assume this is a test tube. It isn't, but assume, hold it very firmly in one hand, go 1, 2, 3, 4, and it's going to be mixed. Go 1, 2, 3, 4, hold it tight. Do not tickle it, that won't mix it. And then what you'll do is light a splint, blow it out so it's glowing, and insert the flint into the test tube. Sort of angle it like this. Again, make sure nothing is flammable nearby and observe what you see. Now, one of the things I forgot to do, and we'll do this after I show you the reaction, for activity number 2, the reaction is, this is a decomposition reaction. The yeast, there's a chemical in the yeast that causes the hydrogen peroxide, H2O, to decompose to water plus oxygen. And you will need to balance this for the lab write-up. Now, one of the things I forgot to do is the following. And what are the indications or the signs of a chemical reaction? Well, one would be gas formation. And how do you tell that? Well, you'll see bubbles form. And if you see that, you've got a chemical reaction. What's another one? Temperature change. What's another one? Color change, significant color change. You have something blue and you add water to it and it's lighter blue, that's not a color change. And the last one is a precipitation. I think I'm spelling precipitation right. And what's precipitation? A solid is formed. And if you see any of these, that means you've got a chemical reaction occurring. All right, let's get back. I'm going to zoom through a little quicker the other activities. In activity 3, you'll have a single displacement. This is going to be fun. And follow what they say, how to put the magnesium ribbon in the one-hole stopper. And you'll put it in the beaker. Now, be careful. You're using 1M HCl, and yesterday you learned M means molarity. This is an acid. This could irritate your skin, and it's not good for your eyes. Really not good. So wear safety goggles and gloves in your apron. And what you'll do, put 10 milliliters in, measure 3 milliliters of the 1 molar HCl into a glass cylinder, or measure it with a graduated cylinder, then pour it into a glass test tube. Add 50 milliliters of purified water into a graduated. Hold the glass tube containing the HCl at a 45-degree angle. Use a pipette to slowly add water from the graduated cylinder containing it till the water goes all the way up the glass. And then hold the glass tube over the beaker, put the stopper in, and with the magnesium, put it, when you push it in, some water, do this over a sink, will drain, and then put your finger, invert it, put it into the water beaker, and watch what happens. Now, afterward, carefully remove the stopper, and then you'll put the flaming splint in there and observe what you see. Now, what's the reaction? Magnesium plus hydrochloric acid gives you magnesium chloride plus hydrogen gas. Instead of using a G, I like using an arrow. This arrow means I think this looks cooler. And this is a reaction you'll have to balance too for the lab. All right, we got a couple more to do and then we'll be through with the lab. In number 4, this is going to be really fun, and do this in a sink or in a metal pan like I told you. Locate the cup containing the vinegar that you used in activity 1. Weigh out 10 grams of baking soda, which is sodium bicarbonate, NaHCO3. Pour the baking powder, do this in a sink, into a small cup containing the vinegar, and swirl it around and observe. Now, I say you can do the glowing splint, and you can try that. If you don't want to do the glowing splint, you don't have to. What's the reaction here? Vinegar is acetic acid, baking powder, soda, that's an NaHCO3, and this forms, this is called sodium acetate, plus water, plus CO2 given off as a gas. And this is actually the first chemical reaction I ever did with my hands. When you're born, your body's doing all sorts of chemical reactions, maybe before. But when I was about 5.5, 6, my father showed me this chemical reaction. He loved chemistry. I wonder why I became a chemist. Don't know. But anyways, you'll have to balance it. Or maybe it is balanced. You'll figure that out. All right. Now, for number 5, again, we're going to be working with a flame. Light your tea candle and hold a small glass tube inverted over the candle. And you'll see some gases collecting there and something form on the can inside the tube. And the cup that had the white vinegar, pour the gas in there and observe what you see. If necessary, they say continue. Now, this you can flush down the chemicals. All right, what's the reaction for 5? Combustion. Well, the main thing in a candle is paraffin wax. And its chemical formula or empirical formula. Yep, that's a lot of atoms. This is paraffin wax. And what you get is carbon dioxide plus water. And you're going to have to balance this. And you also get, which you don't balance, but it's an important thing, heat. And that's the flame. And I actually worked for a company, which it's been sold since the division name changed, but it was called Unichem Chemicals. It was part of Unilever, which is a monster multinational corporation. Unichem itself was quite big with plants throughout the world. And they got started in the Netherlands, in the city, you pronounce Gouda, Gouda, which the Dutch, and I know how to pronounce it because I also know Hebrew, most Americans can't. It's really called not Gouda, it's Gouda. And I worked in Gouda, and this company got its start making one of the 2 chemicals that are used to make candles, and they made candles back about the late 1700s, early 1800s. Yeah, it was that old. In fact, the town hall and the cheese, Gouda or Gouda is known for its cheese. The town hall, which I have a picture of myself standing on the front steps, was old before Columbus set sail. Think about that. It was already old before Columbus set sail. All right, this is a combustion reaction. Last reaction. And that's a precipitation reaction. And here you'll weigh out 5 grams of sodium or baking powder, put in a large test tube. You'll add 10 milliliters of vinegar to this large test tube, or to pour this into the plastic test tube. Place the test tubes in the rack. Both test tubes should be open up. Insert the gas collection in a large test tube. And what you'll do is you'll mix 2 together, put the test cork in with the tube, actually rubber stopper, and then add lime water to a small test tube until it's about half full, and then stick the tube in there and watch what happens. They say mix it 9-10, and you'll see what happens. Now, oh, I forgot in the activity 7. What's the reaction going on in activity 6? Actually, there are 2 of them. First reaction, Forgot a carbon. The tube, well, the first reaction, the vinegar, which is acetic acid and water, and the baking powder form carbon dioxide, sodium acetate, and water. And the CO2 is given off as a gas. And when that goes in the tube to the lime water is calcium hydroxide. And that reacts to form calcium carbonate plus water. And let me check one thing. Yeah, I thought I was wrong. Even Dr. White makes a mistake once in a while. And this is a solid. So you know what's going to happen. And this one you got to balance also. All right. And finally, number 7. And here you'll take some of the steel wool. This be very careful with. And you'll light a candle, use the forceps. When you're doing this, take a very small piece, pull it out like this, do it in a metal tray because this is going to burn and it burns really good. So here they say use the cookie sheet. I wouldn't use an expensive cookie sheet. I go to Walmart and get one of those for $1.24 plus tax, and you'll ignite the steel wool. Be careful. This will be flame. You'll get a good flame. And number 7 is steel wool, essentially iron. The oxygen, you need heat, and that forms ferric oxide plus a lot of heat. And heat would be a temperature change. Now, any of the solids, if anything was burning like your wood splints and all that, I would put it under water in a beaker of water, make sure it's no longer flammable or hot. All the solids I would put in the garbage can, but the last one, the steel wool, it's going to be hot. Let it cool down. Then I'd put that in some water or put it under a tap for some water. Then that can go in the garbage can. All the liquids down the sink, and then let your water run for a couple of minutes after you pour things down the sink. And for the lab, answer all the questions in the lab write-up. Don't forget to take a selfie. I keep on like a regular camera, actually. You'd probably go like this. Boop. I don't know if this will go boop, but don't forget to include at least one picture of you doing the lab. And with that, that's the lab. Now, I think what would be a good idea, let's take a 5-minute break, and then we'll come back and do some chemistry with molarity. I'll be back in 5. I'm back. All right, let's get back to work. Now, yesterday, I was talking about molarity. Let me close some things here. All right, remember, molarity is moles of a solute per 1 liter of solution. And 1 liter equals 1,000 milliliters. Therefore, molarity is moles per liter, but it's also moles per 1,000 milliliters. And if you look in your chem kit, the lab we just did, you'll be using this. A solution, 1 molar HCl. What does that mean? Molarity. Is abbreviated by capital M. And therefore, that capital M tells you it's molarity. And if you have 1 molar HCl, that's 1 mole of hydrochloric acid, HCl, per 1,000 milliliters. Let's have you try one. What does this mean? Your turn. What does that mean? Time's up. Or you could have hit pause right now if you're still thinking, if you're watching the video. Capital M, molarity. And molarity is moles solute per 1,000 milliliters of solution. Therefore, this capital M tells you molarity, and what this means is 2.34 times 10 to the minus third moles sodium chloride, NaCl, per 1,000 milliliters. Let's do one more. What does this mean, and what is the solvent for 2.66 capital M H2SO4 bracket AQ close bracket? Your turn. All right. Ooh, look, capital M between a number and a chemical formula. That's molarity, moles of solute per 1,000 milliliters. So what this means is 2.66 moles of H2SO4. You'll learn later on that's sulfuric acid per 1,000 milliliters of solution. And this aqueous means the solvent is water. Aqueous from aqua, water. All right, now, as you saw in your chem kit, you had a little bottle of what's called a stock solution of different chemicals. And if we were to, and there was 1 molar HCl. If you went to College of DuPage and looked in the chemical storeroom, you'd see they have a lot of bottles on the walls of stock solutions of various chemicals. Why? Well, this allows you to measure out a certain amount, moles, a certain amount of various chemicals that are in those solutions. And that makes this really useful. All right, let's look at this question. 6 points. How many moles HBr, hydrobromic acid, are in 255 milliliters of a 3.667 capital M HBr solution? So as I've taught you all semester, what are you being asked to find? You're asked to find moles of HBr. What are you given? Well, you have 225 milliliters of the solution, and the solution is 3.667 capital M HBr. Well, as soon as you see this, you know, what does that mean? It's molarity, 3.66 moles of HBr per 1,000 milliliters. So how do we begin? Well, the only number we really have to help us out is this. It's hard for me not to use cursive. There. And if you had a ratio, you know what's coming up. What units do you want to get to? Moles. HBr. And guess what time it is? Yep, it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top the units. Whatever I'm trying to get rid of go underneath. I'll write those in. And where do I get these numbers? From this. 3.667 moles of HBr per 1,000 milliliters. Now, before I pick up my calculator, don't pick it up yet, notice milliliters divided by milliliters cancel out. because anything divided by itself equals the number 1, cancel out. I'm left with moles of HBr. And now I can pick up my calculator. And the number my calculator gives me is this. And remember, when you multiply and divide, you get the same number of significant figures in your answer as the answer that has the fewest significant figures. This is 3 significant figures. All non-zero numbers are significant. This is 4 significant figures. Now, the 1,000 is defined. It's not a measured number. So that 1,000 is an exact number that does not play a role in the calculation. Again, the 1,000 is an exact number. So what's the lowest number? 3 significant figures. I'll let you round that off to 3 significant figures. Your turn. Time's up. Keep the 9, keep the 5, keep the 3. That's our 3 significant figures. Use the 0 to round off. Is that 4 or less or 5 or higher? And I hope you pick 4 or less. Drop these numbers. And when you take next week, test number 3, it will say under your name, please use proper significant figures for all calculated answers. And please use 3 significant figures for all atomic masses. All right, let's look at what we did again. We read the problem. We figured out what are we being asked to find? Moles of HBr. What are we given? 255 milliliters. We're also given 3.667 capital M HBr. But as soon as I see the capital M between a number and a chemical formula, I know that's molarity, moles of solute per 1,000 milliliters solution. So this is what I start with, trying to get these units. I use unit analysis to figure out what the ratio is, and I do the math. All right, let's do another one. All right, let's take a look at this one. How many milliliters of a 3.49 molar H2SO4 solution must you get or use or measure out to obtain 1.27 moles of H2SO4? All right, first of all, why don't you, I can give you some time, what are you being asked to find? And the answer is milliliters of solution. What are you given? This, the molarity. How do you know it's molarity? The capital M between a number and chemical formula. And you're also given, you're trying to get these many moles of sulfuric acid. Now, whenever I see molarity, I'm going to use doing calculation. I say, what does that mean? And that means 3.49 moles H2SO4 divided by 1,000 milliliters. So the only number I really have to work with is this. So I will. If I had a magic ratio, what units do I want my answer to be in? Well, we figured that out. Milliliters. And now it's time, I'm going to do it. I'm going to do it. It's time to use your good buddy, your good friend, unit analysis. And whatever we're trying to get to, the units go on top of that ratio. Whatever we don't want in our answer, get rid of, the units go underneath. And I'll write those in. And where do I find a relationship between milliliters of a solution and moles of H2SO4? Right here, because we took the time to take this and say, what does it mean? Capital M is molarity. Remember molarity? Capital M is moles solute per 1,000 milliliters, a concentration. Therefore, for every 1,000 milliliters from here, how many moles? 3.49. Now, if we look at this, notice moles divided by moles cancel out, because anything divided by itself equals the number 1. And now I'm left with milliliters, so I can pick up my calculator, clear it from the last problem. And my calculator, let me erase something here. And my calculator gives me this number. This. And remember, for all calculated answers, please use proper significant figures. This is 3 significant figures, all non-zero numbers. This is 3 significant figures. 1,000 is an exact number. Therefore, you need to round this off, because the number you get should have the same number of significant figures as the number you're multiplying and dividing that has the lowest significant figures. That's 3. So round this off to 3 significant figures, and I'll give you some time to do that. Time's up. Keep the 3, keep the 6. There's a decimal point there. Keep the 3. Use this number to round off. Is that 4 or less or 5 or higher? And 5 or higher, I hope you got that. Therefore, I'm going to drop all this increase this by 1. And that's our answer. Oh, let's do another one. This time, I'm going to let you do a lot of the work, and then I'll do it. I was going to write in cursive again. And the question is, how many moles sugar is 4.67.1 milliliters of a 4.111 capital M sugar solution? So what you should do first, and I'm going to take my time, what are you being asked to find? What are you given? Again, what are you being asked to find? What are you given? And if you want, you can hit the pause button if you need more time, but I'm going to do this. You're being asked how many moles sugar. So we're trying to find moles sugar. By the way, sugar, the chemical name is also sucrose. That's the white stuff you put on in your coffee, tea, or on your cereal or whatever. All right, what are you given? We have 467.1 milliliters of solution. We also have this number 4.111 capital M sugar solution. And you don't have to write down the word solution. And as soon as I see a number, capital M, and then a formula, or in this case, a name, I know that's molarity, which is abbreviated by a capital M. That's moles of solute. Remember, solute is the component of, or components of a solution that are present in a smaller amount than the solvent per 1,000 milliliters of solution. So immediately I can say, oh, molarity, this is 4.111 moles sugar per 1,000 milliliters. And now, how do I begin? Well, this is the only thing we have to start with. If I had a ratio, what units do I want my answer to be in? Your turn. And the answer is, you already figured that out right here. We want our answer to be moles of sugar. Now, what goes unit-wise on top? Ooh, I forgot to write here, milliliters. What goes on top of this ratio? What goes underneath units? Your turn. My turn. Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever units you're trying to get rid of go underneath. And where do we find the numbers that go in here? Your turn. Hence, and we find the numbers from the molarity, which really means this, which means 4.111 moles of sugar per 1,000 milliliters. And notice milliliters divided by milliliters cancel out because anything divided by itself equals number one. And I'm left with moles of sugar. Yay! And now I can pick up my calculator, clear it from the last one, 467.1 times 4.111 divided by 1,000. And my calculator gives me this number. Ten to the zero is one, but if you want to put it down, you can. And now, how do you round that off? You get the same number of significant figures in your answer as the number you're multiplying, dividing, that has the fewest significant figures. I'll give you a hint. This is an exact number. How many significant figures in each of those numbers? Your turn. And the answer is all non-zero numbers are significant. This is four significant figures. Yep, I got it on my rut. This is four significant figures. How many significant figures should your answer have? Yep, you get the same number of significant figures in your answer as the number that has the fewest significant figures. In this case, they're both four. So round this off to four significant figures. Your turn. And the answer is four significant figures. How do you do that? Keep the one, keep the nine, keep the two, keep the zero. Use this number to round off. Is that four or less? Yes. So I'll drop that. And the correct answer here, 1.290 times 10 to the 0 power moles of sugar. Remember, 10 to the 0 equals the number 1. Therefore, you could also write this 1.920 moles. Either one would be correct. Now, it turns out molarity is useful because if I weighed out 467.1 milliliters, I'd know how many moles I'd have, which you'll learn we did where, remember the chemical reactions? You have to know, add how many moles to make something else. Well, here, this helps you. And these are called stock solutions. And question is, most labs make their own, how's my hair look? Good. Their own stock solutions. Well, how do you make a stock solution? Well, let's take a look. And the question is, how many grams HCl, hydrochloric acid, are needed to make 675 milliliters of a 3.33 capital M molar HCl solution? So what are we being asked to find? Grams of HCl. What are we given? 670 milliliters of solution. And this number, 3.33 capital M HCl solution. You don't have to write the word solution down here. And as soon as I see M, capital M, with a number and a chemical symbol between a number and chemical symbol, that's molarity. And that's equals a moles of solute per 1,000 milliliters. Now, I will tell you, there's no way in one step you can convert milliliters to grams of HCl. There's no way you can do that. Well, what do you do? Well, you look at important information, which I've got to open up. You look at important information, test number 3. Notice I give you molarity, moles of solute. Now, for this type of problem, you need the two-step solution. Molarity two-step problems. Step 1, you take milliliters and you convert it to moles. Step 2, you convert moles to grams. You need 2 steps. You need 2 steps. Step 1, you convert milliliters to moles. Well, we have 6.75 milliliters. We want to convert to moles of HCl because that's what we're dealing with right there. And how do you do that? I'll give you a moment to figure out what goes on top, what goes underneath. And the answer is use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of that ratio. Whatever you're trying to get rid of goes underneath. And where do we get these numbers? From the molarity. What does molarity mean? Capital M, moles of solute per 1,000 milliliters. In this case, it's this. So we have 3.33 moles of HCl per 1,000 milliliters. Notice milliliters cancels out. I'm left with the right units. Again, this is step one. You need 2 steps. So now, pick up my calculator. And my calculator gives me this number. And remember, use proper significant figures for all calculated answers. Now, this is 2 steps. There are 2 ways of doing it. I like to round off at each step, or you can round off at the end. For my test and the final, I will calculate both answers. Sometimes they're the same, sometimes they're different. And therefore, this is 3 significant figures. 3.33, guess what? 3 significant figures, and the 1,000 is defined, therefore it's the exact number, and our answer should have 3 significant figures. Keep 2, keep 2, keep the 4. Use the 7 to round off. Is that 4 or less or 5 or higher? 5 or higher, drop that, increase this by 1. So we have 2.55 times 10 to the 0. 10 to the 0 is 1. So it's really 2.25. I think I said the wrong thing earlier. Moles of HCl. Are we done? No. We're trying to find grams of HCl. You need 2 steps. What's the second step? Well, you hopefully learned this for test 2. Step 2 is moles of what you're trying to find to grams. And therefore here we have 2.25 moles of HCl. We want to get to grams of HCl. And I'll let you figure out what goes on top and what goes underneath that ratio. Your turn. Hint, use your good buddy, your good friend. My turn. If you want, hit the pause button while you're thinking about it before you see me do it. But whatever you're trying to get to when you use your good buddy, your good friend, unit analysis goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And where do we get that? Well, in case you forgot, which might have happened, let's look at important information test 3. And notice 1 mole of a compound equals the molecular weight of that compound. And the molecular weight of that compound is the sum of all atomic weights. Well, if you did well on test 2, hopefully you did, you now know that for every 1 mole, that's the molecular weight of the compound, in this case, HCl, hydrochloric acid. The molecular weight, 1 hydrogen, 1 chlorine. The atomic weight, and please use the 3 significant figures for hydrogen, is this. For chlorine, it's this. I'll add them together. Now you get the same number of significant figures in your answer as the number that you add that has the fewest significant figures to the right of the decimal. This has 2, this has 1, therefore 1 is the lowest number. You have to round this off to 1 to the right of the decimal. Keep the 5, use the 1 to round off. That's, guess what? 4 or less, I'll drop it, and the molecular weight of HCl is 36.5. And now, before I pick up my calculator, this cancels out. I'm left with grams of HCl, which is what I want. So now I can pick up my calculator, clear it. And my calculator gives me this number. And how many significant figures should that be rounded off to? I'll let you figure that out first. Your turn. All right. You get the same number of significant figures in your answer as the number that has the fewest significant figures. This has 3 significant figures. I'm in my rut again, 3 significant figures. Remember, the 1 is an exact number. So your answer should have 3 significant figures. Keep the 8, keep the 1, keep the 2, keep the 1. Use the 2 to round off. That's 4 or less. So if you weigh out 8.21 times 10 to the first grams of HCl and mix that so your total solution is a volume of 1,000 milliliters, you will now have a 3.33 molar HCl. Again, you need 2 steps. Ooh, one thing I should point out, 10 points. Yep. All right, now, this is such an important procedure or task, that's a better word, that's done very often in chemical labs, that, guess what? There's special equipment that was developed to do this. And on your screen right now, you see volumetric flasks. And they come in different sizes. They're usually standardized. Oh, this is a good picture. And you see these are the volumetric flasks, and they have a stopper. And let's see if I can get one where you can see the line. This one you can't. See this line right here? That's like a graduated cylinder. And to make 250 milliliter solution, this is a 250, they have all sizes up to So I've used up to 2 liter. Somebody told me they saw a 5 liter. Oh, that's got to be big. 2 liters is pretty big. What you do is you fill it about halfway with water. If it's going to be a water solution, and most of these are, you put it in your solute, and then you swirl it around, dissolve it, then you add enough water so the meniscus comes right to the bottom of that line. And these are very accurate. And then you have the glass stopper, you mix it like this, and you now have your solution. And here you can see they come in very little size. Is that cute? Oh, are those cute? And here you have a 2 liter, 500 milliliter. This is a 10, this is a 5. I have on my couch table, my living room, some volumetric flasks that I bought on eBay. I've got a couple small ones like this. They're a little different. They have a pedestal. Maybe tomorrow I'll bring it up to my office and show you. And these are so cute. Oh, is that cute? And they're so useful. And that's a volumetric flask. And those are used to make stock solutions using the two-step method. Now, if I look at the clock, I think this would be a good time to finish. Remember, there's a lab due today. Remember, test number 3 has been postponed to not tomorrow, or it won't be tomorrow, be a week from tomorrow, I think the 26th. And don't forget, the 27th, the amnesty program is going to end. So if you haven't handed in past labs, this is a chance for you to do it. In other words, handed your labs. And with that, I'm going to remind you tonight, I will have my office hour from 6 to 7:15 on Zoom. Stop by, say hello. If you need any help, I'll be there and I'll help you. And with that, I'm done. I'll say, "Gang gesund, goodbye." I stole that from Granny to Beverly Hillbillies. Bye.